You read the question number 7 and see. One of you please read.
Okay, teacher.
7.
It is given that the gradient function of a curve is ax plus b. The gradient of the curve at -2, 8 is -7, and the gradient of the curve at coordinate 0 and 6 is 5. Find the values of a and b, then find the equation of the curve.
Okay. Now, the first sentence I translate into symbol. Gradient function of a curve is ax plus b. Gradient function means dy dx. So dy dx is ax plus b. Now, the second sentence, you are given two conditions or two sets of values. Two sets of values. The first set is gradient of the curve at -2, 8 is -7. Now this part tells you dy dx is -7 at this point, right? Dy dx, the gradient curve, is -7 at this point. Okay, this is one set of values. You are also given another set of values. The second set of values is like this. Gradient of the curve 0, 6 is 5. It means same as just now, dy dx is 5 at the point 0, 6. Now which set of values I want to use first? The first set of values or the second set of values? Which one should you use first?
Second.
You are given two sets of value. The first set of value is -2, 8, -7. Okay, this is one set of values. Second set of values, 0, 6 is 5. Two sets. Which one you want to use first? First set or the second set? Now, the reason is we have two unknowns there, right? A and B. So we have to try to find the values of A and B first, right? So if you want to find A and B first, which set is more useful? First set or second set?
Second, teacher.
Second one, correct. Very good. Now the second one is more useful because there is a 0 there. Now by substituting 0 inside, you can eliminate one of the unknowns. We see how, right? We see how. Okay, like we see here. Now you are given that at the point 0, 6, dy dx is 5. 0, 6 means x is 0, y is 6. Okay, so I don't have to integrate yet because the value given here is dy dx. So you don't substitute y equals to 5. You substitute dy dx equals to 5. So we're going to substitute dy dx equals to 5. Now this set of value means x equals to 0, y equals to 6, dy dx equals to 5. And we choose to use this set of values first. Okay, so I'm going to show you why you are right. We have to, you know why we're going to use this set first? Because like that, you substitute in 5 and 0. The dy dx, you substitute with 5. The x, you substitute with 0. Now in this way, the value of a is eliminated straight away you can find the value of b. Okay, straight away if you can find the value of b. What is the value of b? 5, right? And I call this 1, equation 1. Okay, right. So I straight away can find one value already because of the x is 0, right? Okay, now we are going to make use of this second set of value. At the point -2, 8, dy dx equals to 7. So what to do? So again, we substitute inside the equation, the dy dx equation. Okay, so when x equals to -2, y equals to 8, dy dx equals to -7. Like what we did just now, we are going to substitute inside. Substitute where? Substitute inside dy dx equals to ax plus 7 because we are given the value of dy dx. So we substitute inside this dy dx. Okay, so how to substitute? The dy dx you substitute with -7. The x you substitute with -2. Now, in this way, by using the second set of values, the a is still there, the b is also there. Okay, so you cannot eliminate any of the unknowns, unlike the set of values that you used earlier, right? So never mind. I call this, I substitute this one, b equals to 5 into this equation here. This one I should call it equation 2. I moved ahead. Okay, I call this equation 2. I call this equation 2, right? I call this equation 2, and I'm going to use b equals to 5. I substitute inside here. Okay, so the -2a I bring to the other side, so it becomes +2a. The b, which is 5, I bring over the other side, it becomes -5. And -7 I bring over to the right hand side, it becomes 7. So I can solve for the no, it's there. I skip the thing. Okay, I can solve for the value of a. I miss out this step, sorry. No wonder you cannot see the 2 there. Okay, right. So finally, a is 6. If a is 6, what is dy dx? You take the 6, put back inside the dy dx. You use the 5, you put back inside the dy dx. A and b, you put inside the dy dx. And what is it? Dy dx is 6x minus 5. How we find, right? Okay. So actually this step I told you earlier, you don't have to show, right? You don't have to show. You can straight away integrate, right? Here dy dx becomes y. Then integrate this thing, 6x becomes 6x squared divided by 2. Integrate 5 becomes 5x plus c. So here we have the arbitrary constant c. Now actually we have 2 points. One point is 0, 6. Another point is negative 2, 8. You can substitute either one of these points into the curve, the equation of the curve, to find the value of C. Which point is more useful? Is easier, not more useful. Which point is easier? You use 0, 6 or negative 2,
0, 6.
8. Of course, 0, 6 lah, because once you put the 0 inside, all these things will become 0. Right? All this becomes 0. And straight away, you know the C is 6. So from here, you can put back the value of C and you get the equation of the curve. Put back the value of C here, you get the equation of the curve. Any question?
No, teacher.
No. Huh? No, then you look at the last question, number 8. Question number 8. This question number 8 is actually the last chapter in Form 5, second last chapter in Form 5. If you look at the textbook, the second last chapter is motion in a straight line. You move along a straight line and you are given displacement, velocity, and you are given either displacement, you find velocity and acceleration, or you are given the velocity, you find displacement and acceleration. So this is chapter, the second last chapter in Form 5. Right? But here they ask you, right? Here they ask, right? So we're going to look at how the second last chapter in Form 5, right? Okay. Someone please read question number 8.
The diagram on the right shows a car being driven on a straight road. It is given that the rate of change of the displacement function of the car is ds over dt equal to 10t minus 2 and s equal to 8 meter when t equal to 1 second. Find the displacement in meter when t equal to 3 seconds.
Okay. Now here you are given ds dt equals to 10t minus 2. ds dt is actually the velocity, right? S is the displacement. You are not given S. You are asked to find S, the displacement, right? So you are given ds dt. Actually is given V. Another symbol for ds dt is V. Okay, so how to get the S? We have to integrate this. So how to integrate? Like that. Of course, you don't have to write all these steps lah. If you don't want, you don't have to. Straight away, you can write out this step. Integrate ds dt, you have S. Integrate 10t, you have 10t squared divided by 2. Okay. Integrate negative 2, you have negative 2t. Then plus the arbitrary constant C. So far okay or not?
Okay, teacher.
Okay. Then simplify. Cancel the 10 with the 2. You have 5t squared minus 2t plus C. So now there's an unknown there, the arbitrary constant. So if you want to find the C, you have to substitute in a pair of values. What is the pair of value? You are given here S8T1. So I'm going to substitute S equals to 8, T equals to 1. T equals to 1. Right? So 8 equals to 5 times 1. minus 2 times 1. So what is the value of C? C is 5. Now, always make it a habit. After you have found out the arbitrary constant, you put back into the equation. So put back into the equation, you have S equals to 5t squared minus 2t plus, don't put C anymore, put a 5 there. Always, after you have found the arbitrary constant, put back inside the equation. Why? Because you may need to use this later on in the question. And indeed, they ask you to find the displacement in meter when t equals to 3. So now they ask you to find the displacement. That means they ask you to find the S when t equals to 3. So when t equals to 3, you put inside the S like this, and you can find out the S is actually 44. Finish. We found the value. S also you have found, the equation for S you found. The value of S also you have found. Any question?